So, hello everyone. Before we start with the presentation, let's all meet Julie. So, for all those who are not there in droidCon America's event, Julie is one of my favorite developers, and she's an Android engineer at XYZ company, and she's working on the ABC TV mobile application. She has recently started writing code in Kotlin, and she is one of the finest developers which you can ever meet. She makes sure that she writes test cases for every new feature she writes, and she makes sure to update the test cases whenever she does any code modification. But she has started encountering problems while testing her Kotlin code. First, Mockito cannot mock or spy final classes. She was using Mockito and JUnit for testing, and she comes across this big limitation with Mockito. She found a few solutions to fix it, like we can make our classes open or we can use interfaces, but these are not good solutions. She moves on to find further solutions. She comes across the incubating feature of Mockito Core and the Mockito Kotlin wrapper, and she's able to test her classes. But that was not the end. There are still more problems with Mockito. Mockito requires boilerplate code when we try to mock Kotlin components like Kotlin objects, and it does not support mocking of private and static functions. PowerMock is often used in conjunction with Mockito for the same, but PowerMock is known for having a reduced code coverage, which she does not want. She goes and tells all her problems with Mockito to her friend Alexei, and he brings up a new mocking framework to solve all these problems. Here enters MockK. Hello everyone, I'm Monika Kumar Jethani, and I welcome you all to this session on unit testing made easy with MockK. I'm an Android engineer at Walmart Global Tech. I'm from India. I'm a chef, reader, writer, speaker, so I like to cook recipes as well as code. And my Twitter handle is at Monika underscore Jethani. I'm reachable on Twitter, LinkedIn, and I'll be sharing my email ID as well. So if you have any queries after the session, you can reach out to me. So moving on to what is MockK. So MockK is a mocking framework, and it has been built for Kotlin. It provides first-class support for Kotlin features like objects, extension functions, top-level functions. It has a DSL style syntax. And before I forget, the extra K in MockK is not because Ekta Kapoor named it. It's because it has been made for Kotlin. To get started with MockK, first we need to include the dependency. Latest version is 1.10 and it supports Kotlin 1.3 and coroutines. MockK is a mocking framework, so while writing test cases using MockK, we follow the same principle of testing, that is, we arrange, act, and assert. For those who are new to testing, arrange is when you mock your data and arrange all of what you need for the test. Act is when you make the method calls, and in assert you verify whether your actual value matches the expected value or not. So let's get started with mocking. Here you can see a class videos repository. So this is a class, and if your application has MVVM sort of architecture where you have your UI controller activity or fragment calling the view model, and view model further calls the repository. In that case, when you are testing the view model, you want to make sure that you end up testing the view model only and not the repository. So in that case, you will be mocking your repository class. To achieve that with MockK, you can achieve it in two ways. Either you can use the at MockK annotation. This is similar to the at mock annotation which was there in Mockito. When you use the annotation style, you need to have the initialization function call in your setup method, or you can have it or you can create a mock without the annotation simply by writing mock and the class name as it's there in the first statement. Now, moving on to the second example of for mocking and verification with MockK. So here you can see that I have two classes. First class is the class under test, and second is the dependency class. So in the dependency class, we have a function calculate result which returns some value, and then we have class under test which takes in the dependency and calls a dependency method. So when we are testing class under test, we want to make sure that we test the class under test only and not the dependency class. So we'll be mocking the dependency class. So to do this with MockK, we create a mock using MockK, and then we'll use the every construct of MockK. So in Mockito, we used to use Mockito.when, and there we used to enclose the function call and use then return and specify the mock result. In MockK, we will use the every construct, wherein we say that for every call to calculate result on the dependency mock which we have just created, it should return the mock result. And then we make the instance of class under test. We use this result, and then we verify you like every and verify are both mock key constructs. Every verify and confirm verified. In verify, we make sure that calculate result method has been invoked on the dependency mock, and then we perform the assertion is will be on normal JUnit assertions. But every and verify are the constructs which you can specify the mock result you would want to return from a particular method, and in verify you would want to verify that the mock method has been called. So moving on to the next example, here we have a class called data service which has two methods, get data from database, which takes in a string parameter and returns a string, and then second is do some operation which takes in a string and again returns a string. So this is for illustration purpose, but in your actual code you will be returning something else. So when I try to mock this class with MockK, first I in the arrange step I'll be creating mock of the data service class, and then I will specify that for every call to get data from DB, it should return a particular result, the mocked result which I want to be returned from the method whenever the method gets invoked. And then I act, that is I make the method call with the parameter, and then I assert, wherein I verify whether the method call has taken place on the mock or not, and then I verify using JUnit assert equals whether the actual result is equal to the expected result. Moving further with MockK annotations, so as I specified earlier that you can create mocks in MockK with at MockK annotation. So here you can see we have a test service class which has two instances of data service, service 1 and service 2, and in the invoke service method we call get data from database on the service 1. So when we are trying to create test case for a test class for this inject test service, in that case we'll be creating mocks for data service instances, and to create mock for the inject test service we'll be using at inject mocks. So with this at inject mocks, we'll be injecting late init vars and vars which have not been initialized. But in case if you want them to want their sorry, which have not been assigned, but in case if you want the values to get overridden, in that case you'll have to use attribute override values, and it is for late init vars and vars only. But in case if you want to use it for vals, when that is possible, you can use inject immutable as well. And because I'm using the annotation style, I have the initialization function call. Now moving on to spying with MockK. So spies, as everyone is aware, is actual object. So if there is a call made to a mocked method on spy, it will return the mocked result. Otherwise, it will return the actual result. So to create a spy with MockK, I use spy k, and first I create the spy of the data service. Then I write the code so that for every call to get data from database on service, it should return a mock result. And then when I make the call to get data from DB function, I get the mocked result. In case if I invoke some other method, like in this case, do some operation which hasn't been mocked, in that case, I get the actual result back. Now, mocks are by default strict. So if we have some method which has not been mocked and we attempt to call that method, in that case, we get a MockK exception. So to avoid that, we can have relaxed mocking. It is achieved using at relaxed MockK, or we can use relaxed equal to true attribute as well. So to create a relaxed mock, you can see here I have created relaxed mock for service. I have specified relaxed equal to true attribute, and then I make a call to that method. So in case of relaxed mocking, it will get the result which will be the default value of return type. So in this case, I'm making a call to get data from database, and because it was returning a string return type and I'm creating a relaxed mock, it will give me an empty string, which is default of string. Now moving on to relaxing unit functions. So that is also possible with MockK. We can use relax unit func equal to true. And if you want to achieve this for a single mock, you use it as a property with the mock. Like in the first line, I'm relaxing unit functions of only service one. And if you want all unit functions should be relaxed for all the mocks in your class, in that case, you'll have to pass the property relax unit func in your initialization method in your setup. Now moving on to mocking objects. Object is a Kotlin construct. So you can mock objects using MockK object. Here you see I have a test object and I have a method get data from database. So when I mock it, I can write MockK object and I get a mock of that object class. So mocks behave like spies. So if you make a call to method which has been mocked, you get the mocked result. Otherwise, if the method hasn't been mocked, you get the actual result. So here you can see when I call the non-mocked method get data from DB, I get the actual result. When I mock the method and then I make the call, then I get the mocked result. So moving on to comparison of mocking objects with Mockito and MockK. So when you mock objects with Mockito, you cannot directly test the object with Mockito. In that case, you will have to redesign your code and use interfaces. In that case, you create an interface. Interface has a declaration for the method. And then when you mock it using Mockito, you create mock of the interface, and then you can tell the mock result using when and then return. Now moving on to unmocking objects. So that can be achieved with unmock all or unmock objects. Unmock objects. So there is a difference between unmocking and clearing when it comes to MockK. So clearing means it clears the internal state of the mock, whereas unmock means that it returns from its mock state to a regular state, a regular object. So moving on to mocking enums. So it is same as mocking objects, like we use MockK object and we specify the enum with the status. Now moving on to capturing parameters. So this was available in Mockito with the argument capture construct. In MockK, it is available with the capturing slot and mutable list. So when you use capturing slot, you want to capture the value of argument passed. When you use mutable list, you want to capture and store the argument values for all method invocations. So you can see here, first I'm creating a mock of data service, then I'm creating a slot of string because the input argument is string to both the methods. So here I'm creating slot of string, and then I specify that for every call to get data from DB, I want to return some result. And then I make a call, and then after making the call, I get the argument captured in the slot, and then I can use slot.capture to get the value of the argument. Now moving on to capturing parameters with mutable lists. So when it comes to mutable list, you can see here I'm creating a mutable list of string, and then I'm mocking the method call. And as an argument, I pass the list because I want to capture all the argument values in the list. And after the method calls, I get the arguments captured in my list, in my mutable list, and then I can use list.size or list of zero to get the actual argument values. So with mutable list, you capture all the argument values for all invocations. Now moving on to mocking constructors. So in MockK, you can achieve this using MockK constructor, and you specify the class name, and then you specify that for all constructed instances of data service, whenever there's a call to get data from database method, it should return a particular result. So here, any constructed data service means that for any constructed instance of data service, so the object of data service will be a constructed mock. After that, you can make the method call and verify the method call on the mock using any constructed again. Now moving on to argument matching. So you can use regular arguments or argument matchers like eq for equals, any for any in your method calls. This is similar to Mockito. Moving on to chaining calls. So here I have a mock for car, and I want to mock the chained call, that is car.door with some parameter dot window state. Then I want to return a particular response. So it is possible using both MockK and Mockito. Now moving on to mocking the hierarchy. So here I have an interface address book which contains a list of contacts, which in turn is again an interface which contains a variable which is again an interface of address which contains city and zip code. So I can achieve this hierarchical mocking as well with MockK. So here you can see I have a mock of address book which contains contacts, which again contains mocks. So either in the inner interface, I can have mocking with the properties like address.city or address.zip, as you can see in the first mock, or I can have mocking the address as a mock in itself. Like you can see in the second mock, I have address, which is a mock in itself. So nested mocking is possible with MockK. Now moving on to verifying at least, at most, or exactly number of times. So in Mockito, we used to use the times property for that. But here in MockK, we use at least two, at most two, exactly one for checking at least, at most, and exactly. And in Mockito, we had this verify no more interactions. So corresponding to that in MockK, we have verify exactly equal to zero. Now moving on to verifying order. So for that, we have a few constructs in MockK like verify all, verify sequence, verify order, and was not called. All specifies that all calls have taken place without checking the order. Sequence specifies whether they have happened in a sequence. Order specifies whether they have happened in a specific order, and was not called specified that mocked was not invoked at all. So the difference between verify sequence and verify all is that in sequence you can miss certain calls, but in order they need to be in the exact order. So here you can see I've created a spy of data service. I make the method calls and then I verify all the method calls. So here you can see that I'm not verifying in the same order in which they were called, because verify all just verifies all the calls without seeing the order. And in verify order, I have made sure that I am calling the I've verified the calls in the same order in which they were invoked. Now moving on to verification confirmation. So this can be achieved through confirm verified, and confirm verified ensures that all the calls on particular mock were verified using the verify construct. So here you can see I created a mock of data service. I mocked call to particular method and returned the mocked result. And after that, I did the method call. And after that I verify the method call, get data from database. So in this case, it confirm verified makes sure that whatever, like here I'm passing the service mock, so it ensures that the all calls to that particular method, which in this case is only one call, which is get data from db, is verified using the verify construct. So in this case my test case will pass. In this case here you see that I am making two calls. I'm making call to get data from database function, as well as I'm making call to do some operation function, but I'm verifying only call to get data from database function. So when I use confirm verified with this service mock, it fails because I'm all the calls are not verified using verify construct. So there are chances where you might want to exclude certain calls. In that case you can use exclude records, and you can specify the call which you want to exclude. Now moving on to mocking functions which return unit. So here you can see I have a mocked class and a function which returns unit. So it can be mocked using every construct, and you can return just runs or returns unit or answers unit. I'll be talking about returns and answers later. So moving on to mocking extension functions. So here you can see that I have a class test obj, and I have an extension function for that. So that can be mocked the same way with every in MockK. Now moving on to mocking top level functions. So if you have a file which has a function lowercase a, and you want to mock it using mock k, even that is possible. You have to use mock k static, and you have to specify the full path name to the file, and then you can mock the method using every construct. Then you can make the method call and verify. Now moving on to answers. So answers is similar to returns. Only thing is returns will return a simple primitive value, whereas answers can return a lambda. So here you can see I have written the same every construct using answers, but I'm not returning the primitive value directly. I'm returning the lambda. So you might come across scenarios in your code base where you have a Java file which contains a static method that is being called in your Kotlin file. And when you are testing your Kotlin file, you need to mock the method of the Java file. In that case, you use mock static, and you specify the file name, and then you mock calls to that method. You use the class name dot method name, and then you mock the method result, and then you verify it. Now moving on to mocking private functions. So it is possible in MockK using a dynamic call. So here you can see that there's a private function method too, and I create, when I'm testing this class, I make a spy of that class, and then I using MockK dynamic call, I use the method name within square brackets, and then I specify what mock result I want. And yeah, here I'm also using record private calls equal to true. The reason is private calls don't get recorded, so they won't be so you won't be able to check them in your verify construct. So if you want to check them in your verify constructs, you need to use record private calls equal to true. And you need to be sure that your method name which you specify in square brackets is exactly the same as your method name. And then you can do verification using any of the verify constructs available in MockK. Now moving on to mocking varargs. So here you can see that I have a function which accepts a varargs. So it's possible to mock it using mockk. We can specify the different parameters we can take as input. Like we can take any integer vararg or some specific integers, or only integers which are less than 5 or greater than 5. We can specify the different combinations. Moving on to the next, mocking coroutines. So mocking coroutines is easier with mockk. Instead of every verify answers, we use every verify answers, and we need to add the coroutine test dependency. After that, you can see here in the snippet, I'm mocking the suspend function call using every, and I specify the mock result in the answers. So you can also verify that calls have taken place within a certain time limit when you use the timeout attribute with verify. So you can specify the time in milliseconds. Here it's 3 seconds, which corresponds to 300 milliseconds. Now moving on to mocking suspend functions. So here you can see that I have an interface with suspend functions, move interactions and find humans nearby async. And the second function is a deferred, returns a deferred result. So when I mock, when I'm testing the suspend function, I use co every in place of every, and then I return a particular result. And then because it's a suspend function, it can be called in another suspend function or coroutine. To execute it, I use run blocking, and then I verify whether the method call has taken place using co-verify. So the same code, the same test which I wrote using returns can be written using co-answers in place of like I return a lambda here, and the rest of the things are same as the previous test. Now moving on to mocking deferred functions. So when you mock deferred functions, you need to return a deferred result. So that's why here I have returned a completable deferred. And again, I'm making the call to the method in the run blocking block. And after that, I verify the result. So now I'll be giving a walkthrough of the demo apps and the test cases which I've written on those classes. So here you can see that I have this presenter class, which is taking the view and the repository as input. So and I have few methods in this presenter class. So when I'll be writing test cases for this presenter class, I want to make sure that I end up testing the presenter only and not the view and the repository. So in that case, I will be mocking the view and repository. So here you can see that I have this fetch data function, and I here in the presenter call is being made to repository fetch data. So and fetch data is giving a result, and after that either I call the view on result or the view on error. So when I'm writing test cases for this fetch data method, first of all, for presenter class, I want to mock the other dependencies which it has. So I'll be calling MockK.
Monika, we don't see your Android Studio. We still see your presentation. Okay, thanks.
Okay, so I'll explain the demo part once again. So here I have this main presenter class which takes in the view and repository. So when I'll be writing test case for the presenter class, I will be having mock of the view and repository because I want to test only the presenter and not the view and the repository part. So here I have this method fetch data, and it's calling the data repository fetch data method, which returns a list of data model. And after that, I make a call to view on result with the data which I receive, with whatever I receive from the repository fetch data, or I'll be making call to view on error. So when I'll be writing test cases for this presenter class, I'll be first mocking the view and the repository, and after that I'll be using initialization function because I'm using annotations, and then I'll be testing both fetch data with a positive and negative for the positive and negative scenario. So in the positive scenario, I've taken the empty list part. So here first time mocking the fetch data, I'm saying that whenever there's a call to this data repository mocks fetch data method, I want to return an empty list. Then I make a call to this main presenter, and I want to capture the result in the slot. So I know the result from this fetch data. Here will be list of data model. So that's why I have this slot of this type. Then because I know it will be a success case, I verify that there has been exactly one call to view on result, and I capture the argument. And after that, on the captured argument, I can check if it's not null and it's empty, because I'm passing the empty list, and that same will be returned from fetch data here and will be propagated here in the on result. And then I can write the negative scenario, a negative test for this. So here, when I'm mocking the fetch data method of data repository, I throw an exception, and then I call the presenter method, and I verify that exactly 0 times result has been called, because it's not a success case, and exactly once the on error has been called. Now, there are similarly for the other methods, I have written test cases. Like here, we have this method wherein I'm making call to fetch data with Rx, which is returning a single list of data model. And after I get the result, I pass it to view on result. If it's an error, I pass it to view on error. So when I'm testing that, I have written the test cases for both the positive and negative scenario. If it's a positive scenario, I am mocking the call to fetch data with Rx method, and I'm returning a single the mock result which I want to be returned. Then I'm making the call to presenter method, and then I'm capturing the data, my arguments in a slot. And then, because I know it's a success scenario, I verify that exactly once on result has been called, and after that I can even do check assertions on the captured arguments. And I can even verify write a test for the error scenario, wherein I mock the method call and I return the error. And then I make the method call, and I capture the data in slot, and then I verify that exactly once that has been called to view on error. And then I can, on the captured argument, I can check whether it's not null and whether it's of type throwable. So similarly, I can write the test cases for other methods. And here we have the log method, and this method gets called in each of the fetch methods in the class. So we can even write test cases for this log method. So for that, I have created a spy of the presenter. I have called the fetch data method, and I'm returning anything, because basically when I call fetch data, I'll be having this call. So I can mock this method call. I just need to verify this log function call. So I'm calling the presenter fetch data, and then I'm verifying that this call, that is log call, has been done once, exactly once, with any parameters. So this is how we can have testing in MockK. And I also have another coroutines based example. So we'll quickly go through it. So here I have a view model, and view model has this get repositories use case class. And in this use case class, I have a suspend function execute, and I want to test it. So, and if it's a success, I update the state of live data to success, otherwise error. So when I test this view model, first of all, I created mock of this class. I create a mock of this class, and then for because that is a I mean this fetch repositories is not a suspend function, so I won't be using any run blocking here. Here I test the positive case, wherein whenever I use co every, and whenever I execute the mock function call on the mock, I want to return a particular result. Then I make the function call, and I verify the value is not null and the status is success. And similarly for error, I can, instead of returning something, I can throw an exception. And this get repositories use case, it is containing a suspend function execute, and it's calling this API repository, which has another suspend function. So we'll be executing a suspend function here. So when I write the test cases for this get repositories, get a use case, then in that case, I will be first creating a mock of the repository, and I'll be executing the method call, execute method call within run blocking, because it's a suspend function. So you can see again, I have for this repository and its fetch repositories method, I have mocked it. I'm returning some result, and then I execute it, and I perform assertions to verify the value. So when I call this method, I run it in run blocking. So now I'll move on to the slide. So there was a limitation with PowerMock that it resulted in a reduced code coverage, but MockK has no such limitations with respect to code coverage. I've shown you given you the code walkthrough, and I have recorded the coverage which I've got from these test classes. And basically, if we cover all the lines of code, we get 100% code coverage. There is no such limitation with MockK, and this is the Jacoco report which I have taken, and we can see 100% code coverage for each of the methods. Now there's one limitation with MockK, which is that it caches the mocks. So you need to use clearing and unmocking to avoid this. So you will find this very rarely when you write and run test classes one by individually. But if you have a batch job which runs a lot of test classes, in that case, this problem might occur. So in that case, you can unmock before or after your class, or unmock before and after each test case. So that was the end of the presentation. Hope you all enjoyed it, and hope you all are geared up to use MockK. Thank you so much. The stage is open for Q&A.
Thanks, Monika, for your talk. We have no questions. We're finished.
Okay, thank you.